Hello students, today we are going to see the new topic acid spaces and source. In today's class we are going to see about the basic definitions of acid spaces and source and classifications of acids. In classifications of acids we are going to see the two types of classification based on their sources, based on the basicity. Okay, shall we go to the class? Okay, so before learn about the definition, let's know some basics about this acid spaces and salts. So generally you would have learned about in lower classes compounds, and these compounds can be classified into three distinct classes, that is acids, bases and salts. So what is acids in general? As we know that it is a sour taste, and bases are bitter to taste and soapy to touch. And salts is a product formed by combination of acids and bases. So when acids and bases reacts together, it produces salts. And it is not recommended to uh, taste the acids or bases because some of the acids or bases are harm to body. Okay. So these acids and bases are recognized by indicators and their characteristics chemical reactions. So what is the indicator? So an indicator is a chemical which indicates by means of a sharp change in color the nature of the solution. So to distinguish, identify the substances by means of the change in color or the nature. So in general we are using so many indicators in the laboratory like phenolphthalein, methyl orange, so and so, litmus paper, litmus solutions. Okay. Now, Lavoisier's and Davies' terms of acids, bases, and salt. Their definitions towards acids, bases, and salts. First, acids. All acids compulsorily have hydrogen as their constituent element in the form of proton, that is H plus. So, which means all acids which are contains of H plus. Examples: hydrochloric acid, sulfuric acid, nitric acid. You can see all these acids H plus or H is being present in this. Proton is being present. Bases. All bases are either metallic oxides or metallic hydroxides or ammonia solution. They are considered to be as bases. Example here: copper oxide, sodium hydroxide, and ammonia. So metallic oxides mean that is O2 minus. Example that for the copper oxide. Metallic hydroxide, that is OH minus, sodium hydroxide, calcium hydroxide. So many examples. And ammonia solution. Okay. Then salts. All salts are chemical compounds. They are formed by the interaction of acids and bases, replacing hydrogen ion present in an acid by metallic ions. So, which means that these as salts have been formed by the reaction of acids and bases while they are reacting with each other. The H plus, that is the protons, have been interact with this metallic ions present in the bases. So, thus the salts have been obtained. Example: sodium chloride, calcium carbonate, and ammonium phosphate. Okay. Now, let's see what is acid. The basic definition. Acids are defined as compound which contains one or more hydrogen atoms and when dissolved in water produce hydronium ion, that is H3O plus ion, the only positive charged ions. So now in acids the only positive charged ion would be the H3O plus ion, that is a hydronium ion. How? When it react with the or when it dissolves in water. So how it get dissolves? Let's see this. First, the acids molecule furnish hydrogen ions in an aqueous solution, which means when the acids are being dissolved in water, it produces hydrogen ion. When HCl reacts with the water or dissolves with the water, it produces H plus as well as Cl minus. But this H plus ion cannot exist independently. So therefore, it combines with the water molecule to form hydronium ion. So already water molecule are present. So with the water molecule H2O, this H plus ion will be added towards it and produces hydronium ion, that is H3O plus. So now this hydronium ion can exist independently. This hydrated ion can now exist independently in solution. This is one example, HCl. Other examples like sulfuric acid, H2SO4, nitric acid, and CH3COH. All these are examples for acids too, which are producing the hydronium ion as a only positive ion. Okay, the acidic property of an acid are actually the properties of hydronium ion present in it. So how this acidic nature of the substance have been determined? It is determined by the hydronium ion present in it. So hence we are usually refers this hydronium ion as H3O plus, and this can also be written as OH3 minus. I mean the is prefixed uh, and the H3 minus should be in the suffix, but the charges of plus is the same, the right hand. So this also can be used because this H plus is the only positive ion present and which is neutral also. Okay, students, and here we have some of the examples of naturally occurring acids like acetic acids were present in vinegar, citric acids in citrus fruits, butyric acids, hydrochloric acids, formic, lactic, malic, oleic, oxalic, stearic, tartaric, uric acids, and they are present in the sources like various sort of fruits items, stings of bees, tomatoes, olive oil, apples, fats, grapes, urine, etc. Okay, then how we are classifying the acids? So that is the classification of acids. So depending upon the sources how we are obtaining the acids, it can be classified generally uh, two. That is organic acids and inorganic acids. So organic acids is nothing but the acids which are obtained usually from plants. They are called as organic acids, and these contains carbon atoms along with the hydrogen atom. So organic acids contain at least one carbon atom and one hydrogen atom. Example here, oxalic acids, acetic acid, formic acid. These organic acids are weak acid because they do not ionize completely in solution. So they contains ions as well as molecules. When these acids are dissolved in water, okay, it produces ions as well as molecules because they are not completely ionizing. Hence, they are called to be as weak acids. On the other hand, inorganic acids, it is also known to be as mineral acids. And example for this mineral acids, here hydrochloric acid, sulfuric acid, nitric acids, these are said to be as inorganic acids. And they are obtained from usually from the minerals. Hence they obtain the name. And these acids does not contain carbon atom. And these acids are known to be as a strong acid because it's ionized completely. And out of these mineral acids, inorganic acids, carbonic acids, that is H2CO3, is a weak mineral acid. Why? When other acids are strong acids, carbonic acid is a weak mineral acid because it contains ions as well as molecules. To identify this carbonic acids, we can use litmus paper or litmus. It turns blue litmus to pink, and this is a non-corrosive and also used in soft drinks. In carbonated drinks is nothing but the carbonic acid what we are drinking. Okay, so other type, that is in this we have oxy acid and hydric acid. In inorganic acid we have oxy acid and hydric acid. What is oxy acid? Oxygen along with hydrogen and some other element. We mean oxygen are present, hydrogen is present with some other element. So they are called as oxy acid. Example, nitric acid. So oxygen is here and hydrogen is present along with nitrogen. Oxygen is here, hydrogen is present along with sulfur. So these are example for oxy acid. Hydric acid, here no oxygen is present but hydrogen and a non-metallic element is present. So hydrogen along with the chlorine, hydrogen along with the bromine, HCl and HP are example for hydric acids. Okay, this is the first classification. Second one, depending on the basicity. The basicity of an acid is defined as the number of hydronium ion that can be produced by the ionization of one molecule of that acid in aqueous solution. So, which means that the basicity of an acid defines the number of hydronium ion that can produced. How many hydronium ion produced? So, hydronium ion is only positive ion which are present in the acids we know well. How many numbers it produces? That determines the basicity. So, based on this, we have a definitions or categories like monobasic acid, dibasic acid, tribasic acid, and also some bases of tetrabasic. That is a 4 basicity. Okay. Okay. First one, monobasic acid. So monobasic acid examples we are given: HCl, HBr, HNO3, HI, CH3COOH, acetic acids, etc. So this what is monobasic acids? So the acids when ionized in water produce one hydrogen ion, which produces one hydrogen ions, and they are known as monobasic acid. Okay, one hydrogen ion produces one hydrogen hydronium ion. Otherwise, I can say one hydronium ion per molecule of the acid. Okay, example HCl, only one H, HBr. Here CH3COO, though 4H are there, when ionized in water, it produces only one hydrogen. Hence, this also comes under monobasic acid. So generally, the monobasic acid ionizes in one step. So it occurs in one step. Because of this one step formation, it produces only one salt. That one salt to be normal salt. Here example we have HCl on reacting with the base, that is NaOH, which gives NaCl. Only one salt it produces along with the water. Okay, with the continuation. So I have told you that why these acetic acids are known to be as a monobasic acid, because of producing only one hydronium ion, positive ion, remaining are being present in the negative ion. Okay, then dibasic acid. Example for dibasic acid: sulfuric acid, oxalic acid, sulfurous acid, carbonic acids are example for this dibasic acid. If you notice this here, two hydrogen ions are present. Doesn't not only mean by because of presence of two hydrogen ion, but also it ionizes in two steps. How it ionizes? Let's have an example. So this dibasic acids ionize in two steps. We can take an example of a sulfuric acid, H2SO4 plus water. So at ionizing H3O plus HSO4. This is the first step. The second step, further this HSO4 is being react with the water and produces one more hydronium ion, and also it gives SO4 minus. So this occurs in two steps. Hence they are known to be as a dibasic acid. So these type of acids, when it reacts, okay, when these type of dibasic acids have two replaceable hydrogen ions and they form one acid salt, one normal salt. So normal salt, which is a neutral, but whereas acid salt means the acidic nature will be more. Okay, so in the first case, it react, it produces acid salt NaHSO4, and this Na2SO4 is a normal salt since it occurs in the two step. Okay, but the other example we will now see that see this H3PO3. Okay, this H3PO3 acid is a dibasic acid. Though three hydrogen is present, it is dibasic acid because it is an oxy acid. Oxy acid, I have told you that is a one oxygen is present, one hydrogen is present with the other element. So this is oxy acid, and when it being formed as a bonding, two OH will be formed. So they are connecting with the hydrogen, and hence it ionizes easily. Whereas the other hydrogen is being bonding with the phosphorus. This is not replaceable hydrogen. So hence it being present along with the phosphorus always. So only two hydrogen is being ionized. Okay, students. Third type of this category is tribasic acid. Example: phosphoric acid H3PO4. Only three hydrogens is present in this formula. Citric acid C6H8O7. 8 hydrogen is present, but it produces or occurs in three steps only. Okay, let's take an example of this phosphoric acid. First step is ionize with water to produce one hydronium ion and H2PO4. Second step, ionize hydronium ion, it produces HPO4 2 minus, and in third step it reacts with the water to form H3 one hydronium ion and PO4 3 minus. So we notice that the hydrogen numbers get reduced to one by one when it reacts with the water because of this formation of hydronium ion. Also, you may notice that this oxygen ions gets increases because from one water molecule the oxygen is being moved towards here. Okay, so 1 minus, 2 minus, 3 minus, like this. So these kind of tribasic acids can form two different acid salt and one normal salt because they occurs in the three steps and three replaceable hydrogen ions are there. So two acid salts will be formed and one normal salt will be forming. Okay, so in this let's see the example that first step obtaining monosodium dihydrogen phosphate NaH2PO4, that is the monosodium dihydrogen phosphate. Second step, disodium dihydrogen phosphate. Third one is, what is this? Na2HPO4. Not this is H. Actually, this is, that should not come. So the formula is just Na3PO4. Okay, the formula is Na3PO4. There is no H. Okay, we'll do it later. Then some acids like silicic acids, which is having a 4 basicity. Okay, so that's all the about this tribasic acids. Now let's see this concentration of acid. You used to say heard about this concentration of acid. So what is the concentration of acid? The amount of acid present in a definite amount of its aqueous solution, that is very small amount of water or no water, is called concentrated. I mean the percentage of water will be more, then it is said to be as concentrated acid. So less water means acid is more water and less acid means that is called diluted. Okay, then how will you dilute an acid? So we know diluted acid. How to dilute the acid? Or otherwise in exam only otherwise called as water is not added to acid. I mean to say, take an acid as a beaker and water in a beaker. To the acid, water should not be added. We have to add acid to water little by little. Okay, so why it is so? As it is in an exothermic process, so much heat of it is produced that splashing in acid solutions may occur. So also the container may break, which can be a fatal to the person. So that is the reason pour acid into water in small amount and stir constantly. So little by little we have to add the acid into the water and stir constantly. Okay, right. Then strength of an acid is a measure of concentrate of hydronium ions it produces in its aqueous solution. Thus, dilute HCl is stronger acid than a highly concentrated acetic acid. So, concentrated diluted is different from strength and weak. Strong acid or weak acid. How the strong acids or weak acid determined by means of the number of hydronium ions present in a solution. Okay, so that is simply we can say this measure of concentration of hydronium ion. Measure of concentration of hydronium ion it produces. So dilute HCl hydronium ion concentration is more. So hence dilute HCl is stronger acid. But corn acetic acid contains less number of hydronium ion. Hence they are weak acid. So compared to that HCl is dilute HCl is stronger one. Okay, so this the strength of an acid depend on the degree of ionizations that we can say as alpha and concentration of hydronium ion. Concentration is the number of hydronium ions are present produced by that acid in aqueous solution. So degree of ionization, that is number of acid molecules ionized. How many acid molecules we ionize? Total number of acid molecules present in the solution. In the total number of acid molecules, how many acid molecules are ionized? That should multiply by 100 to get the percentage through which we can measure the acid whether it is strong or weak. For an example, take and we're taking any acid solution or alkali solution. Okay, if it is greater than 30% strong, so the strong can be calculated by using the formula. It is greater than 30% strong, which means stronger. The concentration is more than 30% strong. Less than 30% it is a weak acid. Okay students, So here in this video, and the next class we will be seeing about this properties of acids, that is the physical properties and chemical properties. Okay, thank you students.